Okay, in this first Castigliano video, we're going to be looking at calculating the deflection at the end of a cantilevered beam using Castigliano. This is called Castigliano energy first. It means we're going to follow the naive Castigliano principle of writing the energy and then taking the partial derivative of the energy with respect to the load. And then we'll look at an alternative way of doing it that's usually faster. And so for the cantilevered beam, if you notice in this picture, X is heading positive to the right. And I'm going to call the 0 point of this coordinate system right here where the load is applied. And so my origin of the coordinate system is at the point where the load is applied. That's X equals 0, X positive to the right. Okay, and any point where I'm going to want to write an equation for the moment, let's say I make a cut right here in the middle of the beam, I have the option when I make the cut and write the moment equation of looking left and getting the moment due to F, or when I make the cut here, where the mouse is showing, I can instead look right, but then I would have to do the statics and understand what this shear force at the wall is and what the moment at the wall is. For that reason, I plan, when I make my cut, to write the moment equation to always look left, which means I never will be looking right, and I'll never have to actually do this statics right here. So that's my plan. And so that's in this math cat, that's what this note says. My origin's at the free end of the beam, positive X increasing to the right. And when writing the moment equations at the cut point, I'm going to look left to determine the moment. Therefore, no need to do the static reactions at the wall. Let's scroll down a little bit. And our Castigliano says that we can write the energy in the structure, the strain energy in the structure properly, and then we will take the partial derivative of that energy with respect to the load to get a deflection. And this is the energy equation for a beam in bending. The total energy, because of bending only, is an integral of m squared over 2ei dx. That's equation 4-18, and we saw that earlier in our chapter, so we're not deriving this, we're simply claiming it right now. And so taking this means we have to write the moment as a function of x, since we're integrating with respect to x. And so looking at the picture back above, the moment as a function of x was simply f times x. I'll scroll back to the picture real quick. When I make a cut where the mouse is, looking left, the moment is f times x. And then, so moment squared is f squared x squared. So I'm going to say that energy is equal to the integral over the entire beam length of that moment of x squared over 2ei, which is f squared x squared over 2ei. And if I integrate f squared x squared with respect to x, I'm going to get an f squared x cubed. And the x cubed is going to generate a 3 in the denominator. I already had a 2 there. That'll give me the 6ei. And I need to evaluate this term at x equal L and at x equals 0 and subtract the 2. And so this thing becomes f squared L cubed over 6ei. And that is the energy in the beam. Okay, and now Castigliano says that the partial of this energy with respect to the force gives the deflection at the location of the force in the direction of the force. So let me take the partial derivative of this term with respect to F. And what I'm going to get when I do that is a 2F L cubed over 6EI. But the 2 over 6 becomes a 1 over 3. So I get FL cubed over 3EI. And if I go to the appendix and look at the cantilevered beam and look for an end loaded cantilevered beam, the deflection at the end from the textbook is FL cubed over 3EI. I didn't copy and paste it from the textbook. You'll just have to trust me on that. This is a match. And that ends Castigliano video number 1, the most naive application of Castigliano, following the words of Castigliano exactly, which says write the energy first and then take the partial derivative. We can see that we can reverse some things and go straight to deflection, and in general it becomes easier. So we'll stop this video for now.